Hi everyone, welcome back to Data Cadence. My name is Rahul and I work as a senior applied research scientist. And in this video, we are going to talk about a very important production machine learning question, that is how to choose the right threshold. So at times you would have built a lot of models for a particular use case, and the most important question there is that once you develop a model, how do you decide the right threshold? So it's one of the important production machine learning decisions that you have to take as a data scientist. And a lot of people would default to saying that zero point 0.5 could be the default threshold, and in a production setting that's not how you should think as a data scientist. And this is one of the interview questions that I've seen a lot of senior folks also are not able to answer with a lot of clarity. If they tell us like they chose a particular threshold, then the question would be like, why did you opt for this particular threshold value? What was the reasoning and the logic behind that? And that's where you need to understand this in a bit of depth. So if you have found yourself confused in how do I select the right threshold, then just stick on and we'll just discuss this further in this particular video. So it's also another important interview question, because often interviewers would ask you like, how would you pick up a threshold given a problem statement? And that's where you need to have a clarity of thought. So you need to understand a lot of things. So there are things like business trade-offs that you would be making. There will be things like precision versus recall. There could be things like cost sensitive optimization, and this in general tests your deployment and production thinking. So a good answer could be that you would choose a threshold which would treat this as a business optimization problem rather than a statistical problem, right? So you got to think from the lens of the business here. And so what typically happens is that most of the classifiers that you will build would output a probability score, let's call it p hat, and the threshold would basically convert these probability scores into decisions. So if your probability score is greater than a particular threshold, then you say that you arrive at a decision using your machine learning model. So the key insight is that you need to choose a threshold that changes. So basically the key insight is that when you are choosing a threshold, you are changing a lot of different tenets here. So basically you would change the precision, you would change the recall, you would also change the false positive versus the false negatives, and most importantly, you would be changing what business impact a particular threshold value will have, right? So I think the first clarification that we should ask as a good interviewee is that like, what is the business objective? What are we trying to achieve here? Because the optimal threshold would also depend on a lot of different factors, right? So it could depend on the business cost, what are the downstream actions that we need to take basis this decision or basis the threshold, and then what are the operational constraints. So these are some of the things that we need to keep in mind. Let's have a look at one of the examples for a better clarity. So let's say that your task is to predict if a user signs up for Amazon Prime or not. So let's say you engineer all the good features, you collect the data, you end up building a good model, and now the task is like, what is the right threshold for this particular model? So let's pick one particular scenario. So let's say that the positive prediction means that you are going to send expensive Prime promotion. Now in this case, the false positive obviously are going to be more costly compared to the false negatives. Why? Because if your model says that a particular customer will sign up for Amazon Prime and they actually didn't end up signing, you would send them the expensive Prime promotion campaigns. So let's say we are doing a marketing campaign, and basis your model, we are deciding whom to spend this marketing budget on. And if you are spending your marketing budget on the wrong people who are not likely to sign up, then that's going to be a problem, right? So in this case, you may want a high precision where the false positives are more costly, and in order to achieve that high precision, you may need a higher threshold value. That's one way to think about it. Now let's consider another scenario. So another scenario could be, let's say missing a Prime subscription is missing a potential Prime subscriber could be expensive for the business, right? So in this case, the false negatives would be costly. Why? Because if your model says that a customer will not likely sign up for Prime, versus actually they do end up signing, so that is a missed business opportunity in this case, right? And in this scenario, you may want to prioritize a higher recall, right? And for that, you may need a low threshold. So ultimately, it's finding the right balance between the precision recall trade-off. And this is again one of the most important things in many business systems that you need to take a call as a data scientist. And then the key insight here is that the threshold tuning is fundamentally deciding the acceptable trade-off between your false positive and your false negative. And towards the end, you would end up choosing a threshold that optimizes the expected business value. That's how you need to think as a data scientist. Let's go further and discuss a few more things. The next important nuance that we need to discuss here is that how do you pick the right threshold value? So there are a few things that you could do. So the first one could be that you could use the ROC curve. So the ROC curve is the receiver operating characteristic curve that typically plots your true positive rate, that is your TPR, versus your false positive rate, that is your FPR. So you can choose the threshold using the TPR versus FPR trade-off. That's one of the most common things. And the way you would do that is you can pick the point closest to the top left corner, which would ideally correspond to a high TPR and a low FPR, because that's what you want. There is one important nuance that when you have a class imbalance, which you will most likely have in a production data set. So in that case, the ROC curve could be deceptively optimistic, because it could give you the wrong notion about your data. So definitely in that case, you should go for a precision recall or a PR curve. And you should choose the threshold based on some minimum acceptable precision and some minimum acceptable recall. So let's say, for example, if your business says that we need at least 90% precision, so you can take the threshold accordingly. And then the last small point is that a lot of people would say that I would go about optimizing F1. So this is one of the most common textbook answers, that people would say that I would pick the threshold that would maximize my F1 score. But the thing is that this only works when both your false positive and false negatives are equally important, or they are equally costly, which is not a scenario that we see in a production setting, because for most of the realistic business problems or problem statements that you might be trying to solve, either false positives could be more costly or false negatives could be more costly, depending on the scenario. So let's say if you were doing this for a fraud detection, basically a fraud detection model, so false negatives would be much more costlier. Why? Because your model would say that this transaction is not a fraud, but what if the transaction ends up being a fraud? So that's where I think that would be an expensive mistake to make. Right. So this is one of the smaller questions that we wanted to see, but it's equally important. A lot of people can't reason behind why they picked a particular threshold. Well, now you know what are some of the things that you need to talk about and you need to think about when you are making these decisions as a data scientist. Thank you so much for sticking around till the end, and hopefully this gave you some new insight into how you would think about and how you would describe these things when you are in an interview setting. And yeah, if you like the video, please do give it a like, and let me know if you have any thoughts in the comments down below, and subscribe for more such videos. Thank you for watching, and stay tuned.